SpaceX just announced it's developing a more streamlined lunar mission plan designed to get astronauts back on the moon faster. Really? And how's that supposed to happen exactly? So, in case you missed it, SpaceX has released a major update on their Starship Human Landing System, or HLS. In that update, they said, since the contract was awarded, we've stayed fully responsive to NASA as Artemis III requirements evolved and have continuously proposed ideas to simplify the mission in line with national priorities. In response to recent guidance, we've shared and are now formally evaluating a streamlined mission architecture and operational concept that we believe can enable a quicker lunar return while also enhancing crew safety. That's huge. But what does that actually mean? Are they talking about an entirely new system? Now, most of you probably know. This sounds like a direct answer to increasing criticism from both current and former NASA officials, including the agency's acting administrator, Sean Duffy, who've claimed SpaceX is falling behind on developing its Starship-based HLS. On October 20th, Duffy mentioned he intended to reopen the 2021 contract SpaceX had won for the Artemis III lunar lander. Shortly after, NASA confirmed that both SpaceX and Blue Origin, which is building its own HLS for Artemis Fourth, were asked to submit new proposals by October 29th. The goal? To outline concrete ways to speed up lunar lander development. Then, during an October 29th conference, former NASA leaders Charlie Bolden and Jim Bridenstine voiced doubts that SpaceX's current Starship design could place astronauts on the moon before China's first planned crewed mission, now targeted for 2030. Bridenstine, who currently works as a lobbyist for several space companies, even suggested that the government consider launching a crash program under the Defense Production Act to develop an alternative lander. SpaceX quickly fired back with a detailed thread on X, formerly Twitter, calling out Bridenstine's remarks and reminding everyone that his clients directly compete for NASA contracts, meaning his comments should be taken with a grain of salt. Bottom line, SpaceX knows exactly what NASA's concerns are. That's why they're now developing a faster, simpler path to the moon. One designed to meet NASA's demanding Artemis schedule while improving astronaut safety at the same time. So what does simplified really mean in this context? SpaceX hasn't shared specific blueprints yet, but in practice, simplification usually means cutting down on complexity. Fewer moving parts, fewer failure points. That could mean trimming cargo mass to reduce the number of tanker launches, shortening lunar surface stays with a 2-astronaut crew, and simplifying rendezvous procedures in a stable lunar orbit. Each adjustment minimizes risk while keeping the mission's core goal intact, safely ferrying astronauts from lunar orbit to the surface and back to Orion. This philosophy fits perfectly with NASA's short-term priorities: reliable abort systems, straightforward docking, and proven life support hardware before attempting longer stays or heavier payload deliveries. Essentially, it's prove the ladder works before you climb higher. How simplified SpaceX's new Starship plan ends up being really depends on how bold they want to get. Elon Musk has already hinted on X that Starship could eventually handle the entire mission, meaning SpaceX might be considering a scenario where Starship alone takes care of everything, no Orion or SLS required. To be fair, SpaceX has already checked off most of the milestones needed to even consider that. Starship has reached orbital velocity, completed successful in-space engine relights, and even survived re-entry. The two major challenges still on the list are orbital refueling and the lunar landing itself. Now, refueling might sound intimidating, but compared to everything SpaceX has already pulled off, it's likely the easier of the two. The real test will be the precision lunar landing. Some of the other milestones, like crewed Earth landings and upper stage reuse, aren't essential for an early moon mission. SpaceX could easily keep Dragon in the mix for that phase. In that version of the plan, Dragon would ferry astronauts to and from low Earth orbit, while Starship would handle everything beyond it. Once Starship returns to low Earth orbit, the crew could transfer back to Dragon for the journey home, if landing directly in Starship still feels too risky. By the time Starship actually carries humans to the lunar surface, we'll probably be much more comfortable with crewed Starship launches and landings anyway. When that happens, the entire mission design becomes elegantly simple. One Starship would launch from Earth, refuel in low Earth orbit, perform a trans-lunar injection, refuel again in lunar orbit, land on the Moon, complete surface operations, ascend back to orbit, top off propellant once more, and then return to Earth. It's a completely integrated system. A single spacecraft type, supported by whatever number of tanker and depot flights are required to fill its fuel depots in both Earth and lunar orbits. The only catch? NASA might not be ready to go all in on that kind of Starship-only mission yet. Political, technical, and programmatic factors all play a role. So instead, this simplified concept might be more of a middle ground, a hybrid approach that leans on the hardware NASA already trusts. That likely means keeping Orion for crew transport, since it's currently the only spacecraft certified to bring astronauts safely home from lunar distances. And while the SLS often gets criticized, it still remains the quickest way to get Orion into orbit, or even high Earth orbit, especially with its funding already secured. If NASA and SpaceX truly want to stay ahead of China, this hybrid setup, Starship for the lunar landing, Orion and SLS for crew delivery, might be the most realistic, near-term, simplified plan. Even if the long-term goal is for Starship to eventually do it all, this kind of hybrid plan could be the bridge that gets us there. Now, it's worth noting, SpaceX hasn't actually shared what this simplified approach looks like in detail. Unless it's a major redesign, it probably won't change the overall mission dramatically. But honestly, that's not a bad thing, because this update gives us more insight into Starship's HLS progress than we've had in quite a while. For one, we finally know just how enormous this vehicle really is. And it's staggering. According to SpaceX's update, a single Starship offers a pressurized, habitable volume of over 600 cubic meters. That's roughly 2/3 the total habitable space of the entire International Space Station, inside one ship. It also includes a modular crew cabin designed for larger exploration teams and dual airlocks for surface operations. To put that in perspective, each airlock alone provides around 13 cubic meters of pressurized volume, more than double what astronauts had in the Apollo lunar module. And for the cargo variants of Starship, those could land up to 100 metric tons directly on the lunar surface, the kind of capacity needed for rovers, habitats, power units, and entire base modules. So when we talk about scale here, we're not just looking at an incremental step. It's a complete rethinking of what a human lunar lander can be. Starship isn't just bigger, it's a whole new concept. The update didn't reveal much about the interior layout, but we did get some fascinating new renders showing what it could look like inside. One image in particular stands out, a glimpse of the cockpit interface astronauts will use. If you've seen inside Crew Dragon, it'll look familiar. Gone are the rows of old-school switches and levers. Instead, a massive touchscreen dominates the console, handling nearly every control function. It's sleek, modern, and unmistakably SpaceX. Now, take a closer look at another interior shot. The view when an astronaut looks upward from inside the ship. Notice anything missing? There's no header tank. For anyone unfamiliar, header tanks are smaller insulated tanks that hold landing propellant separate from the main tanks. They prevent sloshing and pressure issues during re-entry, keeping the fuel stable for precise engine burns. But since Starship HLS doesn't need to return to Earth, those header tanks aren't required, which completely changes the internal design. Instead of header tanks, that upper section now houses the docking system, the mechanism that will physically connect Starship to Orion while in lunar orbit. This allows astronauts to safely transfer between the two spacecraft in space. According to the update, SpaceX's HLS team has already completed 49 milestones tied to the development of Starship's systems, ground infrastructure, and mission operations needed to land humans on the Moon. They also emphasized that payments are only made after each milestone is successfully completed, and that the vast majority have been finished on time, or even ahead of schedule. Some of these achievements are worth a closer look. One major one is the Lunar Environmental Control, Life Support, and Thermal System Demonstration. SpaceX built a full-scale cabin mock-up large enough for multiple crew members to test oxygen and nitrogen injection, temperature and humidity regulation, airflow, sanitation, and even acoustic conditions inside the habitat. Another key accomplishment is the qualification of the docking adapter, the androgynous system that allows Starship and Orion to connect in lunar orbit. It can serve as either the active or passive side, depending on which vehicle it's linking to, and it's derived from the already flight-proven Dragon 2 docking design. They also ran a landing leg drop test using a full-scale model at realistic lunar gravity and impact speeds. That's a huge deal, because they're not testing small prototypes. They're testing full-scale legs dropped onto simulated lunar regolith to study how they absorb impact and interact with uneven terrain. Even though lunar gravity is only about 1/6 of Earth's, Starship's enormous mass means those legs have to be far stronger than Falcon 9's. There's even speculation that they could be self-leveling, which would be a major advantage when landing on sloped or rugged surfaces. Another highlight is the Raptor lunar landing throttle test, where SpaceX demonstrated how the engines can smoothly throttle through a realistic lunar descent profile, a critical feature for such a massive vehicle trying to land gently in low gravity. Then there's the micrometeoroid and orbital debris testing, where engineers evaluated various combinations of shielding, insulation, and window materials to protect Starship from space debris impacts and extreme temperature swings. The landing software, sensor, and radar demonstrations were just as essential. These validated the onboard guidance systems that will allow Starship to autonomously detect and land precisely on the lunar surface. No small feat, given the moon's lighting conditions and rough terrain. SpaceX also completed a software architecture review, mapping out every major control system, which computers they'll run on, how the fault detection and warning systems operate, and how telemetry and commands flow between Starship and mission control. They even conducted Raptor cold start demonstrations using both sea-level and vacuum-optimized engines. These were chilled before ignition to simulate the extreme conditions of starting engines after sitting idle in the freezing vacuum of space for hours or even days. Another critical step for lunar operations. Next came the Integrated Lunar Mission Operations Plan Review, which outlined how SpaceX and NASA will coordinate mission control, flight rules, crew procedures, and overall mission planning. It's a clear sign the two teams are already syncing up on real operational details. Another impressive milestone was the Depot Power Module demonstration, testing prototype electrical systems designed to power orbital propellant depots, a cornerstone of SpaceX's long-term lunar logistics. They also carried out radio frequency communication tests, proving Starship can maintain stable data and voice connections across the entire mission profile using flight-equivalent hardware. And one of the most fascinating tests, the elevator and airlock demonstration, built in partnership with Axiom Space. This test used real EVA suits to simulate how astronauts will move between Starship's cabin and the lunar surface. Finally, there was the medical system demonstration, showing how Starship's onboard medical setup and telemedicine capabilities could enable live communication between astronauts and doctors on Earth, a must for long-duration missions. To top it all off, SpaceX has now activated the hardware-in-the-loop testbed for its upcoming propellant transfer flight test, a full-scale simulation of how Starship will move propellant between vehicles in orbit. Taken together, all of this proves how far the HLS program has come. Not just on paper, but through real hardware, software, and full-scale testing in the real world.